Greetings, grade 9. So today we are going to start learning about marine erosion. So yes, we're off to the beach. In order for us to do this, we are therefore going to be examining changes that take place along the coastline. Now we need to make sure that we understand exactly what this term, the coast or the coastline, is. Very simply, it's the very small or narrow area where the land, the sea, and the atmosphere or the sky meet. So in other words, it is, and I'm going to highlight this all the way along, you will see it's this area all the way along here. That is the coastline. That is the area where the land, the sea, and the atmosphere meet. Now, before we look specifically at marine erosion per se, we need to make sure that we understand what this process of erosion is. Now, the textbook definition of erosion is that it is the process where an agent of erosion wears down the surface of the earth by means of the transportation of particles. So when I talk about particles, when we talk about particles, I'm talking about rocks, stone, sand. And the most important thing about erosion is actually that concept of movement. Let me elaborate a little bit further. When we talk about an agent of erosion, we're talking about quite a few things here. An agent of erosion could be moving water in the form of a river. As that moving river water moves along, so it carries with it stones, sand, rocks. And these particles, as they move over the surface of the earth, they rub against the earth's surface, they tear into the earth's surface, and in this way, eroding or wearing the land down. We can also see an agent of erosion when moving water forms waves. Those waves transport debris and wear the land down. Another agent of erosion is moving air, forming wind. Wind also carries and transports particles that wear the land down, as does the agent of moving ice, a glacier. So let's go back to marine erosion. The agent of marine erosion is, of course, waves. These agents of erosion cause water to move. When we look at that photograph, besides hopefully your reaction as mine was, wow, that is awesome, is also to look hard at that photograph and keep in mind that that is not just water moving, but within that body of water, there are particles. There is, as we say, the load of the wave. That wave is transporting and moving rocks, stones, and sand. And that load will get hit into the rock of the coastline and in that way wear the land down. Now there are many different waves. And the first type of wave that we are going to look at are waves that we refer to as destructive waves. Now look hard at those photographs. Without considering specifics at this point, I want you just to look at those photographs and to pick up the sense that destructive waves are powerful waves. Look at that. Imagine yourself standing on those rocks over there. I think that you can see by looking at that photograph that if you were standing on those rocks and those waves broke against you, you would be swept off those rocks into the ocean. The power of waves is actually tremendous, and this power makes them very, very efficient agents of erosion. Now, before we go on to discuss destructive waves in any more detail, I do want us to understand two concepts when talking about waves, and those are the concepts of swash and backwash. So, let's begin by talking about swash. Swash in our diagram here is shown by this arrow. Now, swash is the movement of water up onto the beach. If you take your imaginations to your last beach holiday, you will remember sometimes when swash gets particularly strong, it causes people to jump up and move back further up the beach because the water moving up the beach is in danger of wetting their towels. The next concept that we need to understand is the concept of backwash. Now, backwash, as that arrow shows us, is the movement of water back down the beach into the ocean. Now, do you remember the feeling if you are standing in the shallow part of the ocean and the waves are lapping up and just coming up sort of up to your knees max or up to your ankles even? Have you ever experienced that feeling when the waves have broken and they start pulling back and going back into the ocean? Sometimes the power of that backwash is so strong that it actually causes your feet to sink deeper into the sand. So there you have felt what the backwash is. So the swash is the movement of water up onto the beach after the wave has broken, and the backwash is the movement of water back down the beach. Right, let's relate all of this to destructive waves. Remember the destructive waves? We looked at that photograph where we saw very, very high, powerful waves. So destructive waves tend to occur during stormy weather, and this causes the waves to be very high. This makes sense. When wind blows, it blows on the surface of the water. This moving wind drags the water along with it, causing the water to move as waves. So during stormy weather, the wind is strong, and the stronger the wind, the higher the waves. Destructive waves occur frequently. In other words, they occur often. As one wave forms and breaks, the next one comes in closely after. An important concept about destructive waves is the fact that it has a strong backwash, but a weak swash. So when this destructive wave breaks against the coastline, the movement of the water up onto the coast and up onto the beach is not very much. But the pull of that water back into the ocean is tremendous. If we have a look at this photograph over here, we can recap what we've just said. So right up here, it says the waves occur close together. In other words, frequently. As one wave is formed, So the next one is formed just behind it as they move towards the coastline. We then see over here, they tell us they are steeply sloping waves. In other words, these are very high waves that break and plunge and crash into the rock making up the coastline. Here is a diagram showing us destructive waves. When you guys get back to school, we'll give you a chance to actually sketch this illustration, showing, in a recap, that our destructive waves are high, that they break against the coastline with great force, and the most important thing is that they have an exceptionally strong backwash. Now, these characteristics of destructive waves create the power of moving water as waves. Just have a look at that photograph. I think you can understand why they are called destructive waves. Have a look at that. So high, hitting into the land with such force. And as that wave hits into the land with a powerful impact, throwing the rocks, throwing the sand, throwing the stones that it has been carrying into the coastline, you can imagine the force of that. It breaks pieces of the land away, and then with the tremendous force of the backwash, as that wave pulls back into the ocean, so it takes with it parts of the land that it has broken down. Let's move on to have a look at the features, the landforms that these destructive waves create as they erode, as they wear the land down, and as they change it. Wherever there are lots of destructive waves, we will see that there are rocky coastlines, no beaches at all. Those destructive waves hit against that rocky coastline, breaking pieces of the land away. And as the force of that strong backwash that I keep talking about pulls back into the ocean, so it carries away bits of the coastline with it, destroying the land, breaking it down, and resulting in a rocky coastline. The next feature that I would like us to have a look at is sea cliffs. Now, we all know what a sea cliff is. There we see it over there. The land has a vertical, very steep drop into the ocean. Now, because this cliff is subjected to the erosive power of destructive waves on a continuous basis, these cliffs get eroded away and they move. Let's see what I'm talking about. These are fantastic photographs to show us this process of the movement of cliffs. Looking at the very first photograph on the left-hand side, this cliff gets eroded by destructive waves as these waves break against the bottom or the base of the cliff. Can you see how all the rock at the bottom of the cliff, over here where I am actually trying to draw a cross, has been eroded away? This means that the rock lying above this, the overhang of the rock, has no support. Obviously, this will cause the overhanging rock at the top of the cliff to collapse. Before we move on to the next slide, have a look at this photograph over here, this arrow here. That is showing us the bottom of the cliff where the rock has been eroded away by the breaking waves, pulling the land away, wearing it down, and creating a wave-cut notch. Now, this diagram shows us in a fabulous way how cliffs move. As the cliffs get eroded away at the base in a process called undercutting, because the waves are cutting away at the rock under the cliff at the base, this causes the cliff to move back. Let's have a look more closely. Have a look at the part of the diagram labeled 3. I'll put a cross there, over here. That is where the cliff was originally. However, destructive waves had eroded the land and had undercut at the base or the bottom of the sea cliff, causing the land above it, the overhang, to have no support and to collapse. Due to this portion of the cliff collapsing, and of course being carried out to sea, this resulted in the cliff having to retreat back and being found at the position as indicated by number 1. In time, the waves will continue to undercut the bottom of that cliff, causing a wave cut notch over here, and will in turn then cause the cliff to retreat even further back. So that is why you need to understand that due to the process of erosion, the land is dynamic. It never stays the same. It is changing all the time. As cliffs retreat and move further and further back, this eventually forms a wave-cut platform. Look carefully at that photograph, and the arrow that I made over there is pointing to this flat platform of rock in the front of the cliff. And as you can imagine, as this cliff over here retreats backwards, so the platform of rock in the front will become bigger. Now, cliff retreat actually causes lots of headaches for man. You can see how people's homes along the coast are actually collapsing and falling into the ocean as those cliffs have retreated. Man has attempted and made use of many different measures to try and control the waves and to try and slow down cliff retreat. They form sea walls and groins. Groins is really just a fancy word for a seawall, where we construct walls of concrete, and the waves will of course break against the concrete, and in this way we hope to slow down the erosion of the coastline and therefore slow down the process of cliff retreat. Let's look at some other interesting features that the erosion of waves has formed. My story begins with a land feature that we call a headland. So a headland is this whole area shown here, where it's a piece of land that juts out from the mainland into the ocean. Now look carefully at the photograph of this headland. I want you especially to turn your attention to this part of it. Do you see that the sides of that headland are full of cracks and crevices? Now these cracks are points of weakness where the rock is a little bit softer. And over many months, and in fact many years, the destructive waves will come, they will break against that headland, and they will pick away at the lines where the rock is much weaker. After many, many years of this process of erosion, that headland will get eroded away. And what we start to see is where those cracks in the headland were, we start to see the formation of a sea cave. And over here in the second diagram, you can see the second sea cave. Now listen carefully to me. For the purposes of my story today, I want you to visualize that there is a sea cave that we can see. But directly opposite, on the other side of the headland, the side we can't see, there will be another sea cave forming. So there are two sea caves directly opposite one another, separated by a wall of rock. It's almost like you could visualize these people rowing their little canoes or their little boats into the sea cave. Their friends are on the other side in the opposite sea cave, and they're banging on the wall of rock that separates their two caves. Now, obviously, the destructive waves, when they're very strong, move into the sea cave and break against the wall of the sea cave, eventually eroding through that wall of rock separating the two caves. In other words, the two caves will meet, and this will form a sea arch. Look at that. Isn't that amazing? Well, as you're looking at that, I think you will also pick up the fact that a sea arch is never going to be a permanent feature. Have a look. That roof over there, over here, I'm going to do a little cross over there, has got absolutely no support. So obviously, in time, the roof of that sea arch will collapse. When the roof collapses, we then get a feature that we call a sea stack. You could call it an offshore stack, or simply a stack is good enough. Look at that. Is that not amazing? Visualize, use your imagination. In times past, there was actually a whole roof of rock that would actually join this stack to this headland over here. Over time, through erosion, that offshore stack becomes smaller and smaller. It gets worn away to eventually form a stump. That stump could also be referred to as a rock island. There is a diagram showing us all these features that we have just spoken about. Let's look more carefully at it to make sure that we understand what's been going on. So, there's our headland, our piece of land jutting out from the mainland into the ocean. Do you see all these little cracks over here? These lines of weakness over here. Have a look at this one over here. This is particularly a big crack, which over time may form a cave. If there are two caves directly opposite each other, eventually the wall separating the two caves meets, and eventually what do we get? We get a beautiful sea arch. In time, however, the roof of this sea arch is going to collapse because it has no support, and we therefore are going to get the formation of an offshore stack, which will get worn down, become smaller and smaller until eventually we see a little stump or rock island. Obviously, that stump or that Rock Island is going to disappear completely, as this process of erosion is relentless and never stops. Look at those amazing photographs. Let's look at the big photograph at the bottom of the slide. There's our cliff with our headland. There's our cave. There's an offshore stack getting quite small there, almost a stump to my mind. And finally a stump. And here you see how stumps just get so tiny and eventually they just disappear completely. There's no sea arch in this photograph, but have a look at the smaller photograph at the top. There we see our sea arch. And I don't think it's going to take very long before the roof of that arch is going to collapse. Dynamic change, this relentless, never-ending process of erosion causes our land and our coastline to change dramatically all the time. Have a look at those photographs. I tell you what, these agents of erosion, waves, can form the most amazing formations. Those two photographs that I'm showing you in this slide are actually a feature that we call a blowhole. This is simply when the waves have eroded away a hole in the roof of the cave. And there we see the sunshine shining right through into the depths of that cave. Actually, quite beautiful. So that grade 9 pretty much covers the features that are created through the tremendous and very powerful erosive ability of destructive waves. I hope this has made sense to you. And you can go back and you can look at these photographs because those photographs show us exactly how these processes take place.